Welcome and thank you for joining us with our DCRU session. It's Webinar Wednesday 2506. In this session, we'll talk about, I guess a lot of people may have heard about the changes in the standards. So we're going to cover the topic DCRU explained. We're going to offer 2 steps to PoE reliability in infrastructure, maintenance and testing. So there's a lot in the title. There's a lot to go through today. So welcome and join us. This is the Trend Networks Academy, your trusted knowledge partner for all data network technicians and maintenance professionals. Our solutions provide proof of performance. We remove the guesswork when installing and maintaining commercial networks. I'm Gordon White and welcome. This is a very interesting topic. I'm looking forward to sharing it with you today. So we're spotlighting DCRU. We'd like to unwrap the explanation of what that particular test parameters are, what the effects are. We'll give you some solutions today, and at the back end, go through some of the fundamentals of PoE, deploying PoE. Let's get started, and all of your questions are welcome. Please, we do have a chat line at the end. You may add your email address. Should I miss anyone, I can always get back to you. But I will be waiting for at least 5 or 10 minutes if you'd like to have, or if you have a question, we'll cover it just after this session. Thank you again. So, our session today revolves around the upgrade of 4-pair PoE. 60 and 90 watt PoE now delivers higher power, greater functionality. There is a variety of products available and in use today, with the uptake expected to increase. Enhanced testing at the component level is essential. So when we're talking about DCRU, we're talking about an extra sets of tests at the component level, essential for long-term reliability. So resistance unbalance was identified as crucial for reliable operation of PoE. In this session, we're going to share how to deploy it, how to make it reliable across structured cabling systems. Once again, for those which are familiar with PoE, we'll introduce you to it, the changes. So power over Ethernet, the next generation, which is now 60 watt and 90 watt, has an inbuilt feature. So that's the official 90 watt IEEE 803.BT standard has an inbuilt cutoff. So should it detect a resistance imbalance considered as a potential to overheat and cause fire, it cuts out. So the idea is to protect the equipment as we're adding more power down that line. So that's the big difference here. And this is why DCRU is so important. So let's take some steps and look at what we already know. We already know power over Ethernet is deployed practically everywhere in office applications. We know it's quite common. And in the 2-pair applications, it's quite reliable. There's not much to do because vendors have built the product very well. Cabling vendors also have very good component level constructions, and installers are pretty good at what they do. It is the advent of the 4-pair variety which we're going to focus on today. So it's focusing 60 and 90, deploying 60 and 90 watt solutions is where we need to do this additional testing. And of course, in a building, we may not know which cable is going to be used to deploy our 90 watt solution on. So therefore, everything across the infrastructure now needs to be tested for DCRU. So the picture here is a building with a bunch of callouts, a lot of callouts here, from Wi-Fi devices, camera devices, LED lighting. Doesn't necessarily mean they're all high powered, but you may choose to use one of those lines. For example, I've pointed out something in the center, which could be a digital signage board, and would see the introduction of a lot of digital signage coming into buildings. And typically those systems would like to use a 90 watt device to power the monitor, the information screen, as well as send the data information to. So with that case, this is why now we've got to test across the whole infrastructure. So deploying PoE is quite common. It still covers its 2 standard methods. Primarily, first is a PoE injector, quite popular because a lot of legacy switches are out already, or if you need to upgrade to a higher power, you have a switch. You can then add the added PoE injector and to match the device that you add on. And that might be a security IP camera, an edge camera, a higher power Wi-Fi, or of course, a potential display monitor. And the other method, if you'd like to consolidate your system, could be a straight switch and PoE device together. And this is where power over Ethernet budgets are critical when you start designing from the first point of application and operation. So think about the importance of doing a PoE budget right from the outset. Okay, one of the questions could be for DCRU, why bother? Is 60 watt, 90 watt really going to be deployed in my area? And we see this a lot because a lot of people are happy with their solutions they have now. But the truth is, we are seeing a lot of people migrating slowly towards these products. And not only is it one or two, but there's a huge variety of vendors which supply 60 and 90 watt products right now. I'll just pick one example, which is Edimax. And there's a lot if you Google. And not only is it one product, but it's a multitude of products from Wi-Fi, edge cameras, digital signage, informations for kiosks, so outdoor information displays, PoE lighting, access control, IoT sensors. There is actually a lot coming our way. So yes, this is important. We need to do this now. In fact, that's why in November 2024, the TIA made that step to make it mandatory to test for DCRU. And that's a part of this important webinar that I'm doing today. So I'm really excited about this one to share this with you. So just confirming why DCRU is now added to this mandatory testing. What is it? I'd also like to share our two-step testing process to look at PoE reliability as we move along. Okay, so in the LANTech solution, the Trend Networks LANTech, we've actually always been testing for DCRU. So prior to the TIA making it mandatory, we have always been capturing that data in the back of the tester. But to make it easier for you, to help you select which test standard, we've put a little PoE or plus PoE next to that standard. On screen, I've got a display of the LANTech, and when you're selecting standards, it's got a Cat6a and a plus PoE. You may select that. Another one that I've highlighted is the Max standard. That's a great standard which captures everything. Users also have the ability that if they've tested with a LANTech, they could go back and recertify. That means you don't need to go back on site. You could just recertify because we captured the raw data first time, every time, whenever you've tested with LANTech 4. Okay, so that's the important aspects there. Now, moving forward, modern PoE must consider 90 watt applications. And again, we're looking at the difference is it's the addition of 4 pair, the addition of adding PoE potentially across all 4 pairs. The challenge is now focusing on infrastructure to manage heat, because there's a few things which start happening when we start adding extra power down those pairs of cable. So again, just summarizing that for those which are very familiar with power over Ethernet, it's the combination of power added across a cabling system, injecting power and data down the cabling system. Okay, traditionally done on 2 pairs, now we're adding 4 pairs. Okay, as we add 4 pairs, we now start looking at the balance across all of the pairs. And it becomes a bit of a challenge here to make sure is the resistance equal across all those 4 pairs. So managing heat, managing balance, we've got to start looking at all of these items. There is a couple of additions I just need to highlight here. We will sweep those up on the back end of this section. We're going to talk about heat management and environmental impact, temperatures, and temperate zones in various countries. We need to consider those. But let's focus on, right now, DCRU testing and what is it. So what is DCRU, resistance and balance? I mentioned the cable. And one of the core elements of a cable is the twisted wires or twisted pairs inside. So DCRU looks at the terminated link entirety. So that's the connector, the cable, well, pretty much connector cables and the whole thing together. And what it's going to do is a resistance check across all of those elements. There's three parameters. We'll cover those in a moment. But the challenge is pairs inside a cable are twisted at different rates. You can imagine it's quite noticeable when you look at the blue pair. Typically, the blue pair is twisted the most compared to the brown. However, I've got a shielded product in the center of the screen. Sometimes shielded products are not twisted as well. So sometimes the twists in a shielded system is not as well. Well, UTP is typically twisted more, highly more. You can see that blue compared to brown, whereas the twist in shielded is a little less, close to being equal. So cables are designed in various types, subject to noise immunity, and different manufacturers do things differently. So what this means is we have to apply a series of tests across those links, and it's the cable balance which is very, very important. Let's take a look at that. So DCRU is fundamental first step. There is more to deploying DCRU than more to PoE than just the DCRU step. So what I'd like to introduce now, I'll just take a pause. As we move through to explain DCRU, I'd like to do it this way. Let's look at it in our method, a two-part process, a two-part test method for PoE reliability. And firstly, we look at the component level testing, which we'll go through in detail, those three parameters for DCRU. The second part is looking at power delivery, the power of PoE, whether it's coming through at the end. Okay, so this is a very, very important element, and I hope you enjoy this section. This section is the two-part process. So first part is, of course, DCRU at the component level. So part one, we need to do our resistance test, our resistance unbalance test. So number one is certification. Certification is perfect because we use a device, electrical frequency device, to scan the complete cabling system. And what we get is we're able to capture electrically the map of those particular components across the whole link. In fact, for troubleshooting, this is the best device. So certification is critical for electrical resistance testing and for diagnostics when you need to solve problems. So that's part one. And this is where we see those three parameters for DCRU come into play. So again, what is it? Looking, if you can remember, I talked about the cable pairs. We're going to do three parts of those cable pairs. And I mentioned the twist rates. So on screen now is I've got some of the twists, some of the pairs, and we'll talk about standard loop resistance. So what we're looking at really is each individual pair pretty much looped back. So I've got on one side the tester, just from one end of the tester, it's just going to look at the resistance across that cable per pair. Okay. The second step now looks at the pair and we look at each individual wire. So yes, these tests happen very, very quickly. In fact, Lantec is going to do all these tests in 7 seconds. So we're going to do a loop resistance. We're then going to look at each individual pair and apply a test across that. And then lastly, we're going to capture those numbers and we're going to compare them across the group. So I'll just take a step back. These two tests, what is the loop, then what is the individual wire, and then the comparison. And we're typically trying to keep them within 7%. Right now, 7% was selected as the best method to say that is the best to try and allow manufacturers to have a DCRU balance across that cabling system. So let's see what happens next. So if we can have our balance across that cable and we have a resistance within an amount, which is, by the way, a very fine tolerance, what design or designers of high power systems were able to do was they built an inbuilt cutoff system for the PoE switch. And the idea is, and I've got this information from R&M, fantastic job they did, by showing A balun inside the PoE device is looking for um, uh, the balance between the system, and if that saturation point is unbalanced, it simply cuts out. So that could be a part of the cable itself unintentionally getting hot, or maybe through the environment. But first of all, the most important thing is, have we terminated it properly? Have we put the right connectors on? In fact, is the cabling type right? Have we gone over length, creating more resistance? So all these things are factored in to make sure that our transmission would work. So if it gets too hot because of environmental factors, this balun could shut off. So that's the whole point. PoE 90-watt was intended to be safe with a cutoff mechanism. Okay, and the most important factor is making sure our cable balance is correct. So troubleshooting, if we're looking at troubleshooting, there's a few tips just on screen. So of course we'd always certify. We need to certify first. If we certify, I've just put a bunch of things on the screen, and the idea is we can go to our certifier and we can start picking up some of the diagnostics to find which end is the problem. In some cases, insertion loss, where we put cables in over, or we install cables over 80 meters, because we typically expect cables should work at 90 meters, it, it may be a problem for us, depending on the type of cable. And so insertion loss can play a problem. Patch cords, I must mention, patch cords can be a real issue because typically we do a permanent link test and then we allow the patch cords to stay on site. Sorry, the end user to add his own patch cords as we leave that site. So I'd also recommend try and get PoE rated patch cords as they pose the biggest performance degradation. And lastly, there is a range of cables out there. Always seek a reputable vendor, reputable cables. There is CCA cable out there, and they are fine for short links, but they are not PoE rated. So be aware, the copper clad aluminium is not designed for PoE. Okay, so I mentioned patch cords. Let's have a look at that's why it's important to do part two. Just going to move to part two in a moment. Before I do that, let's give you the summary. Consider the impact if we ignore DCRU. Consider this as that we're uncertain if the link will perform reliably. Troubleshooting PoE becomes more difficult because we can't identify, was it the cabling components? Did we select the right infrastructure? This is why you need to do all these added tests now. And of course, it's the cost impact. Ask yourself, is it really possible to go back and test some of those sites which are now live, installed, and operating? Well, if you've done that with the Landtech, we can certainly look at that live data. We can recertify it for you, but remember, it's live. So if it's live, it might be hard to go back and change those links. So always do turn on your DCRU testing, test at that point of installation. And of course, Landtech 4 solves all the above. It always includes DCRU. So again, that little tip as we move on to part two. And so this is a really interesting webinar today. Adding part two adds in this challenge of what happens when you leave the site. So you've done your DCRU testing, and a lot of businesses look after clients with their service work. Well, I'd like to introduce you to another product called PoE Pro. A part of the installation process is a multifunction wire mapper. This is what I'd recommend. So PoE Pro is very, very interesting, and we're going to show you how you can use it for the two-part process. When we pull in cables into a building, typically it is not ideal to have a certifier in your hands at that time. There's a lot of dust, a lot of debris, and people are working in a construction environment. A small handheld tester is perfect to wire map, pin test, trace cables, and make sure both ends are terminated correctly. And this is where we introduce a multifunction verifier. And so what is that? This is the PoE Pro. And we'd like to introduce a really good method of fast installation of using this wire mapper, and then you would certify the link. And of course, you now have the option, which is the second part, where the PoE Pro can come back online and do a load test when it's live against a standard, and we can send these reports, just like the Landtech, together into the cloud. So you can now report with a load test that you are able to see PoE. Okay, so not only can we load test, by the way, we can take a photo as proof of operation. So what is this load test? And what is this part two? So if we've done our DCRU testing, we've used the PoE Pro to first pull in the cables we've certified, and now it's live. If you're responsible for delivering the product, you're an integrator, you can now test your device for PoE delivery, whether you're doing a short run, a long run, or you may be taking a risk and doing an extended run. Let's go through some of these concepts. PoE Pro, or Part 2, allows you to test against the PoE standard. So we're not talking about DCRU now. It's the application of power standard, which is the 802.3bt standard. Okay. So first of all, what we can do is we could look at the device delivery, and we have a setting in high, which looks at the power coming out at the injector site. The second part is after we add cable, we have a resistance loss, and it allows for 90 meters. So it will give you pass fail for the minimum expected amount. So you can see here that if we look at 90 watts, we would have 90 watts expected out of the switch at the point. However, at the end device, it would be 73 minimum watts that we would expect to see as the minimum pass rate to achieve 802.3 BT class 8. Okay? And that's the idea. So without having to remember or know all of these standards, we take all of that away from you by providing a device which simply does pass-fail against a standard, and you can create a report. So part 2 is critical once it's live. This is for the service team. So power delivery troubleshooting requires a load tester. So let me talk about load. So it's just going to do a brief load test to make sure that you can actually get power across that link, as if not a verification, but as if you're testing that switch for its power delivery. So it tests the links for length over the power. It tests the power supply, tests at the power supply and at the endpoint. And this is where it's also capable of at least testing the patch cords. The biggest issue is the patch cords. A lot of the products are typically not PoE rated out there, and it makes sense. And they can work on a short link. It's possible. We've seen the introduction of 28 AWG and 30 AWG is a big concern. However, they can work on short links. How to test? Well, at least you can apply a load tester. And lastly, always check your switch budget. Have a look at your switch budget. If you're adding a lot of PoE devices, this can be used to check or put a load on the switch, but you should really see, can all of my devices operate at the same time? So that's simply the ability to calculate all the devices which are added, look at the switch budget, and then see if they meet each other. Okay, see if they match. So just to summarize now, we saw that our certifier saved us with the uncertainty of the cabling components. We're now starting to wrap up on the two-part process, that the part 2, we can now tick the box to say that our PoE Pro, our live power test, removes the uncertainty that will the link perform reliably, and the speed of troubleshooting is reduced. This is important. So I hope I'm doing a good job with getting this message across, that is that if you test for DCRU at the first point, the point is when you get to troubleshooting when PoE is live and it's not working, you can troubleshoot quicker. So you can say, well, I know that my components are good. It's more likely a switch or a device problem. So you could focus on that. But when you haven't done DCRU, you've now got to do a device check, a cable and component check, so your time is extended. If the infrastructure requires repairs on cabling system, it also will take longer again, because you've now got to change out cabling components. So this is also why it's important to do DCRU right at the start and do your maximum certification best practice right at the start. So think about the cost impact to go back to that site to retest as well. So I hope that makes sense. I hope that helps a 1 and 2 part process. I mentioned this webinar is quite hefty, a lot to go through, and on the back end, we'll talk about some very interesting things about deploying PoE reliably. So it doesn't certainly come into the testing element, but these are important factors that we would like to share because this is intended to help. So we'll briefly cover temperature derating, environmental factors that are really, really important to know. So what are cabling vendors saying and why it matters? There is a lot of fantastic cabling vendors out there to talk with. Please do that. A standout I found was the R&M team. This is a part of the technical document. So again, there's a lot of others. They're all doing a fantastic job. But R&M did have a lot of technical data, which is very, very interesting. And what I found was they were saying that the PoE would work on a link alone, and we see that typically. The challenge is when you start putting bundles together, and we see that often, it's where environments start to heat up, bundles start to heat up. And I'm just going to move to another screen where from Molex, another great vendor. So I mentioned there's a lot of great vendors out there. They did, and of course, most vendors have done a lot of work around this to show an example of bundles and how they start heating up. So we're not suggesting that there's going to be a fire on these bundles. That's not the case. But what we're saying, it affects reliability. Remember that there's that cutoff switch in the balun in the 90-watt devices. So as heat starts increasing in bundles, we have a problem. The other thing is consider our pathways. So the previous screen, we had bundles, we had pathways. Vendors had detected that there's a bit of heat in those cables. Now let's think about this in real terms. Cables are running in roofs, in some parts plenum ways. However, it's when you go into posts or external poles to mount Wi-Fi systems, cameras, these posts, poles, or connecting pathways can heat up. And this is where we really, really get tripped up. So please think about that. So external heat plus PoE plus length reduces reliability. So I'm just going to summarize this now to try and bring it together. It's a bit hefty, isn't it? So DCRU is important to look at the components across our system. The part 1 and part 2 test method helps us look at can PoE work across the total link. And now the important consideration is how am I deploying it and where am I deploying it? And there's another factor is temperature derating, something we all forget. So I hope you're enjoying this because there's a lot in this subject and it's really, really exciting to share this with you because there's a lot to learn about deploying this amazing system. Well, temperature derating has always been applied to cabling systems. And if we look at it, without the advent of PoE, we already had a derating system shown on screen already. And if we look at 30 degrees, we already start to see that our 90 watt is not there. It's down to 87 on UTP cables, at 88 for STP cables. So everything we had assumed was actually reduced anyway without increasing the heat. Now imagine if you've got a small pole where you're running your cables up and along, or you cannot control, and that temperature could increase very quickly to 40, and you're already coming down to 84, you're already coming down to 87. So you get the idea that very, very quickly, without applying PoE, without applying a system. So one of the ideas is adding a PoE calculator. A lot of vendors do this, and I've just got this one from R&M, so thanks to the R&M team, but there's a lot out there. Again, a lot of fantastic vendors have this information available to you. Please do contact them. Think about a PoE calculator. And so what it's going to do, it's going to look at temperature derating, where you can add the ability to pick a temperature to estimate what could be the impact on those runs. Okay? Very, very important. So we've taken away a lot of the pains, I hope, today. The most important tips we're going to summarize now is let's bring all this together. So Number one, always check with your cabling vendor on infrastructure design. Think about some of the things we talked about today with deploying in bundles, deploying where heat is a challenge, simply deploying for extended runs where you're going to do this, and enable airflow where possible. Apply your temperature derating and consider that you could get a PoE calculator from some of these vendors. Okay, it is recommended. And lastly, you've got this fantastic option for trend networks that I've shared today on a part one component level testing and part two application delivery, application service delivery. You have the ability to go in and work with your team, work with the end client to ensure he's got reliable PoE. And lastly, some vendors do offer PoE rated patch cords where reliability is paramount. Use the calculator and make sure PoE patch cords are deployed and specified. Once again, I hope that helps. I'm going to be available to share and help with any questions. I'm really glad you joined us on this session. And thank you for joining us. And please join us again soon for our next session. So we'll be picking up questions on your chat line, and I'll be available for the next 5 minutes. Thank you again. I'm Gordon White from Trend Networks, a product education manager. I'm here to help, and I look forward to any questions in any way of which I can help you. Hi, I got a question here from Bob, Bob Ham. Thank you for asking. And that is, will my Lantic 3 be able to do this? Sorry, Bob. What with Lantic 3, it's a fantastic product. It was designed prior to DCRU being completely ratified and specified. And no, it's not able. It is a hardware change. We need to change the hardware. And that's why we moved to Lantec 4, a completely new system which captures the DCRU in the background in 7 seconds across every test. So that was what that change is. I hope that helps. Bob, thank you. Another question. So, a question from Bob Ham was, will this be available to show my team? Yes, we'll make this available on the Trend Networks YouTube channel. Once again, there's loads of information there, so we can ping that out to you roughly in the next 48 hours. Thank you, Bob. Hi, I've got an amazing question from Clint. Thank you very much for joining us today. Is there a difference in PoE testing between Trend Networks, SignalTech 10G, and the PoE Pro for application load testing? No, Clint, the hardware in both products is the same. SignalTech 10G is an amazing tester able to test through network switches. Fantastic. In fact, if you have one of those, you can use that to check the bandwidth right at the very end. So I talked about two elements: DCRU testing for component level testing, the ability to use a PoE Pro to check will my device deliver enough power. You have the SignalTech 10G. The SignalTech 10G can now put a PoE Pro style test on a link, as well as you can do a bandwidth test from the end device back through the switch. So you have the trilogy. That is the best and ultimate infrastructure test. So I hope that helps, because you can do proof of performance for commissioning. If you have a critical service, such as maybe a communication system that must not go down, SignalTech 10G could do a 72-hour test across that link. I hope that helps. Thank you again.